Hello, I'm Miss Kara and welcome to Ice Cores, Nature's Time Capsule. We're going to talk a little bit about what ice cores are, where they come from, what they can show us, and then we're going to unwrap our very own homemade ice core. So thanks for joining me and let's dive right in. So what are ice cores? Ice cores are cylinders of ice removed from glaciers. And glaciers are formed as snow compacts into ice. Winter snow and summer snow are different in both chemistry and texture. So glaciers form as layers of snow sort of pile up on top of each other. Each layer of snow is different in chemistry and texture. Summer snow is much different than winter snow. As time passes, the buried snow compresses under the weight of the snow above it, and that turns it into ice. So stuff that was in the air called particulates and dissolved chemicals that were captured by the falling snow become a part of the ice, as do any bubbles of trapped air. So as the layers accumulate over seasons and years, they create a record of the climate conditions at the time of formation, including snow accumulation, local temperature, the chemical composition of the atmosphere. That includes greenhouse gas concentrations, volcanic activity, and solar activity. So where do ice cores come from? Ice cores are collected in Antarctica, North America, Greenland, and Patagonia. They can be drilled anywhere in a glacier or on an ice sheet in any continent in the world. So if you think of mountains that have snow on top of them all year round, sometimes ice cores will be pulled from there. Some are removed with hand augers, which is that picture on the left, and some are removed with electrothermal drills, which is that picture on the right. The oldest continuous ice core records go back to 130,000 years ago in Greenland and 800,000 years ago in Antarctica. So what can ice cores tell us? Remember how I said all of that stuff gets trapped in the ice and the snow? So all of those chemical compositions, all of the little bits, the particulates trapped in there, any gas trapped in air bubbles, all of that can tell us about catastrophic events like volcanic eruptions or asteroids coming through the atmosphere and burning up. It can tell us about nuclear testing. They found nuclear isotopes in some ice cores. And it can tell us about climate variation by measuring the amount of chemicals that are in the ice. If you want to read more in depth about ice cores, you can visit icecores.org or you can visit antarcticglaciers.org. Now before we get started to dissect the ice core that I have made, let's run through real quick about how to make your own ice core. So what you're going to do is get an empty Pringles can, and then you're going to get some water. And if you want, you can use carbonated water, the water with bubbles in it. You'll need some liquid paint or food coloring, and then some ash or some dirt. So you're going to fill 2 cups with water. You're going to put food coloring in 1 cup, and you'll leave the other plain. And then you're going to put clear water in the bottom of your Pringles can, about 1 inch thick, and that will be your winter snowfall. So winter snowfall shows up as clear. And then you're going to put that in the freezer until it's frozen solid, and then you'll pull it out and you'll pour your colored water in there, and that is your summer snowfall. Summer snowfall is colored, and if you look at an ice core that's pulled out, you'll see that it has these alternating bands of color. And the reason that summer snowfall is colored is that it melts just a little bit from the intensity of the sun before the winter snowfall lands on top of it. So because it melts, it's a little more dense, and that's what makes it appear colored. And you'll keep alternating your clear water and your colored water until you run out of water or you run out of tube space. If you want to, you can put a little dirt in there or a little ash in there to simulate what it would look like if there was a volcanic eruption and all that ash settled on your ice. And then once everything is frozen, then we can take it apart and look at it, and we're going to do that next. So hold on to your horses. Okay, are you ready to dissect this ice core? So what you'll need is a tray of some sort to catch the melt. You'll need your prepared ice core. Can you see that in there? And then I also have a pair of scissors because sometimes this doesn't want to tear. So let's see if I can tear it. Nope. Gonna need a pair of scissors to open it up. All right, here we go. Whoop. Here we go. Here we go. Whoa. I forgot to put on my gloves first. I'm gonna want some gloves because ice is cold. Handy dandy gardening gloves. Here we go. We're gonna open that up. See, now I can hold it without it hurting my hands. Oh my goodness, you are not gonna believe what happened. Well, this is very, very funny to me. Okay. So if you get a close look, you can see at the top, I've got some really good layers. But in the middle, I'm not really sure what happened there. I'm not really sure. You know what? I have a suspicion. So did you know that inside of your freezer, it's not the same temperature all the time? And then it goes through a cycle of being on and freezing, and then it melts a little bit, and then it freezes a little bit. And I think what happened was, in that cycle, my colored ice, my colored water condensed into the middle, and then it refroze with the clear water on the outside. So while it looks really cool on the bottom, it does not look like an ice core. So let's just take a look at what we can see with the top of the ice core. I'm gonna lay this down and I'm gonna move the camera so you can see what I see. Okay, so as you can see from my goofy ice core, this is so silly, I don't even know what to do with myself. As you can see with this goofy ice core, the top half, right, we can see our layers, sort of. Oh, here, I'll pick that up. Right, so that dark band in the middle, I put some stuff in there to simulate ash so you can see it. And when scientists are measuring the stuff that's in here, what they do is they set it upright with the oldest part on the bottom. They set it upright, and then the bottom part is a plate that gets warm. And then next to that is a tube, and that tube acts like a little vacuum. So it melts off, right? And they collect the water over here, and then the tube that's here acting like a vacuum is sucking up all of the air that's coming off of this melt. And they're gonna run that through a computer program to see what kind of chemicals are in there. And you can kind of see some air bubbles in the top of this up. Like there's one there, and there's one right there. So, yeah, and this band is lighter than that band, and that band is darker than that band. It's a little disappointing that it turned out this way, but c'est la vie. That's the way it goes sometimes. So you might think, well, you got an ice core and you've melted it and you've got all this data, but how do you know that it's true? How do you know that it's accurate? Well, that's the reason that scientists drill them from all over the world. So you can have an ice core from Greenland, which is towards the North Pole, and an ice core from Antarctica, which is by the South Pole. And if you melt them, you can compare the amount of chemicals in it, or sometimes they both have an ash line from a volcanic eruption. It's very cool that they're able to do this. Additionally, in addition to doing ice cores, scientists also drill cores from the bottoms of lake beds and from the seafloor to get more information about the composition of the atmosphere before those places were lake beds and seafloors. But because they're protected with water, they haven't been messed with, which is pretty cool. Thank you for joining me today on ice cores. I hope you get a chance to do a little freezing and melting on your own, and I hope that it helped you to become more curious about the world around you. I'll see you guys next time. Bye!